Now let's look at making this PyTag attribute configuration a general case. Currently, the name of this PyTag is just hard-coded. So if I create another tank, it will not point to the correct PyTag. For example, if I make a new tank. Oh, I need to fix the name. Tank 2. When I go and look at its attributes, look at the PyTag that we're pointing to. That PyTag is tank1.level. Oops, wrong PyTag, right? It's hard-coded. So one option, of course, would be just changing that manually, or of course in bulk. I mean, we've got bulk editing tools, they're out there, or I could do this in code, of course, but that's kind of a pain. It looks like my PyTags follow a naming convention, so let's try to exploit that. I'm going to undo what I just did there, and go into the tank template. Within the tank template, we can take a look at all these PyTags that we have for level. Looks like for all of these level tags, it's the name of the tank dot level. Cool, okay. So in fact, there's an item in PyAsset Framework called substitution parameter syntax. And what substitution parameters can do is they can allow us to say, use the name of the element, like tank1, dot level, to resolve each PyTag. So now with that setting made in my template, if we look at tank2, tank2 in fact points to its own PyTag. So does tank1. And it all happens automatically following that naming syntax specified once in the template. Of course, if this fails for a given tank, I can always make a manual edit, but this is really my 80% or 95% case, is that I can map PyTags automatically. Are they always that pretty? In real life, no. Your PyTags will look a lot more complex, but using this substitution parameter syntax can get you a long ways there. So now that we have capacity and level taken care of, we can proceed putting together the attributes that will lead us towards our business goal at hand. Well, if I know capacity and level, I can start thinking about volume. So let's edit the template and add an attribute which will somehow display volume. The template will add a new attribute for volume. Now, since the capacity is in US gallons, I'm going to go out on a limb and say that I will want to know the volume also in the volume of US gallons. As for where this volume comes from, I don't have a PyTag that tells me volume, and of course it's not a constant. But I do have a PyTag that tells me level, and I know the capacity of this regularly shaped tank. So I can multiply the two together in this simplified example. And that operation seems trivial enough that, come on, we're multiplying two numbers. This is something we could do with an on-demand formula. And in fact, PyAF has just such a mechanism. One of the data references we have is the formula data reference, where I can import parameters to use in a formula, like C for capacity, explicitly in US gallons, L for level, explicitly in %, and then volume just becomes something like capacity times level divided by 100. Life looks pretty good. The result of that, of course, if capacity is explicitly US gallons, the result is also explicitly in United States gallons. You'll notice we are setting this in two places, but they hold two functions, and we will talk about that a little bit later on. So now we have this formula configured, which hopefully for each tank will show us volume. And in fact, if we look at each tank, there's now a volume attribute for each tank, calculating on demand, volume. And for as far back as we have history for the level, we can look at the history of our volume. It's all calculated client-side on demand by this formula data reference. If I know volume and want to take volume and somehow arrive at the mass of my tank, then I need to know the density in the tank. And if I want to know the density of whatever's in the tank, well, I need to know what's in the tank. So let's add an attribute to track what material is in the tank. If we go into the template, we can add a material attribute. We could say the material could be just about any string that we put in. But that doesn't seem really safe for enterprise use and for integration and everything. I'd rather have a predictable set of materials, because my corporation really has a finite set of these. So instead of allowing just any string, we're actually going to look also over here in the library at the enumeration sets in AF. We can create a new enumeration set to hold all of the possible materials that could go in a tank. This is analogous, of course, to the enum functionality of .NET and of Java and many other languages. So I've got possible materials here. In my enterprise, we use 3 materials. There is methanol. There is methanol's much more exciting cousin, ethanol. And we need something to mix that ethanol with, so we get some Diet Coke. Now that we have our materials enumeration put together, we can use that as the value type of that material attribute. So instead of just being any string, it can be specifically one of the allowable materials. Maybe by default, it's methanol. Let's go look at our tanks, and see if they picked that up. Sure enough, they did. Each tank has a material, and I can of course change that and apply my changes. And life looks pretty good. So we will continue from here by looking up density for this material. If we know the material in our tank, we can associate that with a certain density of that material. That'll help us calculate mass. So we add in a new attribute, of course, to hold this this density. Density is going to be a numeric type. Let's go ahead and set that. It'll be a single precision type. And this density is really just going to be a material property. Now in real life, yes, maybe it's dependent on various factors, but for our example, for any given material, that material is going to have material properties, such as density. Now this is the kind of information that we would have laying around in a spreadsheet somewhere, or maybe in a SQL or Oracle database. The point is, we have a table of this hanging around somewhere. And that's exactly the kind of information we can expose into the PyAsset framework. In the library, there's an object called the AF table object. We can make a new AF table that will hold our material properties. Now it's entirely possible to grab directly from an existing SQL table or something, or in fact establish a dynamic link to it. We're not going to do that right now. Right now, we're going to go the manual approach to really see the mechanics. So instead of importing a table straight out of SQL, we're just going to define our own table schema. We really need a table of material properties telling me what the name of the material is and what its density is. So density can be a numeric type, and we can even give it a unit of measure here. Density, we're going to be measuring it really in specific gravity, which is kilograms per liter, just relative to water. So in the table, let's hammer in some of these materials. Okay, go for some numbers that look believable. And there we are. We have a table exposing material properties where if I know my material, I can look up its density. Now the way we connect this to the tank is we have a data reference that can do lookups out of these AF table objects. In the tank, we will set our density attribute to use the table lookup AF data reference. We'll configure this. Okay. So we want to look up out of the material properties table. The column we want is density. That's what we're looking for. And we want this when we want to find the row where the entry in the table is equal to whatever the value of my tank's material is. If my tank's material is methanol, find the row where it's methanol and grab its density. So we set this up and we say add and. In other words, add that condition to what's being generated, which you might recognize is a SQL statement. Okay, now this data reference was smart enough to know that the table measures density, or the table contains density, measured in kilograms per liter. But we still need to do that other step of, on the overall attribute configuration, how do we want to see this? And we want to see it as density in kilograms per liter. Again, we'll see this whole unit of measure contraption in action a little bit later. Right now it seems like 2 unexplained steps, but it'll make sense later. So there we have it, density configured to do a lookup. If we check out the elements, there's tank 2. It happens to contain methanol, and automatically looked up is a density of 0.94. For tank 1, which has the infamous Diet Coke in it, its density is also looked up on demand. It's important to note, though, the architectural and design purpose of this AF table object that's powering the table lookup. When we do a table lookup, our AF client is requesting the entire material properties table to be pulled down client side from the server. The client does the lookups from that, and life goes on. But your performance is going to be very heavily hit if this table is enormous. We're talking thousands and thousands of rows. It's a lot that has to get potentially pulled from a foreign system, packaged up, sent across the network, and then your client starts doing lookups from it. So a good rule of thumb for the am I doing the right thing here test is a table of about 5,000 rows. You got fewer than 5,000 rows, you're probably on the right track. You're not abusing the AF table per se. But if you have more than that, maybe it'll work, but there might be some better options. So just keep that in mind.